Hi guys and girls, today we're looking at the probability assignment and the family babies question. Okay, so essentially the way this question works is a family has two children and those children can either be boys or girls. Okay, and you've got to draw a tree diagram showing all the possibilities of boys and girls. Okay, now I'm going to do a tree diagram, but I'm just going to do it a little bit differently, so I'm not giving you the answer. Okay, it's going to be heads and tails. Where you see head, you're right. Female or F. Where you see T or tail, you're right. Male or M. Okay, so let's get started. A tree diagram looks like this. It starts with nothing, then goes to first child, or my first toying flip, and that can either be heads or tails. Okay, then for the second flip, if I got heads the first time, I can still get heads the second time. I can get tails the second time. Okay, for my second flip, if I get tails, I can get heads the second time, or tails the second time. Okay, and just to finish it off, I record the possibilities. So head is my first possibility. Head tail is my second possibility. Tail head is my third possibility. And tail is my fourth possibility. Okay, and that's all the possible outcomes of flipping two coins. Okay, now this second question gets a little bit trickier. Okay, here we've decided that males are that little bit more common than females. Okay, so it's just slightly more likely to have a male child than a female child. Okay, so we've got to adjust the probabilities and write down which outcome is more likely and support your answer with mathematical calculations. Okay, now the above tree diagram we're going to redraw because that'll help us with our mathematical calculations. Okay, and again I'm going to pretend that I've got a coin that flips 60% of the time heads, thus 40% of the time tails, and is slightly weighted in favour of one than the other. Okay, so your job is just to take the numbers and the calculations I do and do it with the male, female, okay, as opposed to heads, tails, and do it with these numbers, the 0.515 and the 0.485, as opposed to the 60% and the 40% I'm going to do it with. Okay, so just to demonstrate, you've got head and a tail, head and a tail, head and a tail. Okay, now just so you can see the numbers in green, I'm going to put my 0.6 above there and my 0.4 above there. My 0.6 and my 0.4, my 0.6 and my 0.4. So I put them afterwards because I'm running out of space above, but they should really be above. But we can deal. Okay, now next to it, I do my calculation side of things. And I'll do that in black. So that's 0.6 from my heads times 0.6 from my second heads, and that equals 0.36. Okay, 0.6 times 0.6 equals 0.36. Okay, and that's just heads 0.6 times heads 0.6 equals 0.36. Heads 0.6 times tails 0.4. 0.6 times 0.4 equals 0.36. 0.24. Okay, heads 0.6, tails 0.4. 0.6 times 0.4, 0.24. Okay, as getting a heads the first time doesn't affect getting a head or a tail the second time, we can just times out the probabilities. Okay, so to continue, 0.6 times 0.4 equals 0.24, and then 0.4 times 0.4 equals 0.16. Okay, and so thus, for me, the two heads is more likely, because, so I just highlight 0.36 is bigger than 0.16. Okay, and we're done. Hopefully that was helpful. Bye guys and girls.